You're listening to Tech Innovator, the podcast dedicated to cutting edge technologies brought to you by IEEE Techverse, Sri Lanka.
Hello and welcome to the second episode of Season 2 of Tech Innovator podcast series brought to you by the IEEE Techverse Sri Lanka. With Tech Innovator, we bring to you the latest cutting edge and bleeding edge technologies. This segment fully focuses on advancement of technologies and their applications. I am Eranga Kodithuwakku, and today with me I have Mr. Pasan Pethiyagode, who is a chartered electrical engineer with 8 years experience in power distribution and control systems. He is also co-founder of YUGA, a tech startup. He is an electrical engineer graduate from University of Moratuwa, and also he is an IEEE volunteer with sectional and regional experiences. He was the chairman of IEEE Young Professionals Sri Lanka for the year term 2016 to 17. Hello, Mr. Pasan. Welcome to the podcast. It's an honor to have you with us today.
Thank you so much for inviting me, Eranga.
Yes. So today we are going to talk about renewable energy sources under the topic Renewable Energy for Greener Sri Lanka. So, world is an amazing creation of nature. It has enough resources for living beings, but due to the misuse of natural resources by humans, restrictions have to be imposed on how we can use them. As of now, scientists have predicted the fossil oil deposit will run out in 2052. World is in fuel crisis, and the renewable energy topic has come out to the podium like never before. Sri Lanka is also suffering from the fuel crisis more than the other countries in the world. Renewable energy is the solution that can heal people as well as the mother nature. So we thought to talk about more on renewable energy sources, about the best fit for Sri Lanka with Mr. Pasan. So there are several types of renewable energy. Generally we define renewable energy as energy that's generated by natural processes that continuously replenish. In the world, they use hydraulic power, solar power, wind power, ecolic power, and many more. So, Mr. Pasan, let me ask first, what type of energy sources are used in Sri Lanka, and in which capacity are they working?
Thank you so much, Eranga. Thank you so much for the introduction as well as the first question. Let's discuss this with related to Sri Lanka majorly. So in that case, you were very correct when you said that renewable energy sources are the sources which does not run out, or we usually call it that they are not depleted. If you take it another way, when you have a coal or fuel oil, as we know it, we know that we have a level to which they are being deposited in this earth, and at the same time we know that one day they are going to run out. But renewable energy sources, just like wind, solar energy, are not going to run out. So this is the basic idea of that. So coming to your question, if you talk about Sri Lanka, we do have hydropower, we do have wind power, and we have solar power. So if you look at, I would like to first give you a general understanding about power generation in Sri Lanka, just to make sure that you get things right during the podcast. So if you look at the Sri Lankan energy system, we do have a lot of power plants of different sources distributed across the country, and they are being connected through the national electricity grid, which usually runs at 132 kilovolts or 220 kilovolts. So this is the backbone of Sri Lankan energy network. And that goes down to 33 kilovolts when it comes to the distribution level, and then further comes down to 400 volts when it comes to our houses or other commercial applications. Which means we have a power system where the power plants feed in power to the national grid, and we use power at the other end of it. Now, having this in mind, if you think about the total power system as a cluster, we do have hydropower about 1,400 kilowatts installed. At the same time, if you talk about wind, it was megawatts. And if you talk about wind, we have around 248 megawatts installed. We have mini hydros around 400 megawatts installed, and the rest is coal and fuel oil. So if you talk about the percentages, we run about 50% in terms of installed capacity on either fuel or coal. We have the balance 50%, around 30% hydro, 6% wind, and the rest being mini hydro. And you might wonder why I don't talk about solar, because solar would come at a different level. Usually what we know is that solar does not work as a power plant, just like a hydropower plant or a thermal power plant. So the solar, as you know, would come on your rooftop or on a ground in the size of 1 megawatt in small scale and be fixed into the Sri Lankan energy system at a different level. They do not get connected to the national backbone. They will be connected locally if you have rooftop at your house, or if you have a small power plant, to the closest grid substation at 33 kilowatts. What I wanted to tell you is, at the end of the day, we have a power system which is across the country, to which we have renewable energy sources, namely hydro, wind, and solar, connected at different levels. So you might wonder why I wanted to tell you they are connected at different levels. Why can't we just forget the national power system and talk about wind, solar, or hydro? Why I don't do that is, when it comes to the next levels of this discussion, I'm pretty sure this particular question will be important. So answering your question, we have hydro, we have large hydro. As you know, it could be Victoria, Kundale, Randenigala, Rantabe, and then Vimala Surendra, Canyon, Lakshapana from one side, as well as we have mini hydros, particularly around Ratnapura area where you have a really good rainfall. We have mini hydros, particularly the Eranga area. And then we have wind, majorly in Jaffna and Putlam, where we have the highest wind potential, but we have some wind in Ambayagala area as well. And then we have solar, and solar would come either on your rooftop, as you usually see, or in small solar parks. Usually we have it around 1 megawatt to 10 megawatts, the maximum in Sri Lanka. So yeah, these are the renewable resources we have. That's hydro, wind, and solar, connected to the national electricity grid at different levels.
Okay, Mr. Pasan. So in these days, we face several power cuts per day. So the main reason being power generation depends on fuel. What can we do to scale up to our national power grid from renewable sources?
That's a very interesting question, and you accidentally related to my previous answer without knowing that, possibly. When you talk about scaling up the renewable energy generation, the next important question that comes to our table is that, is our national electricity grid is ready to do that? Because as much as you have renewable sources, as much as you have energy generated from renewable sources, the system or the power system should be able to transport the energy you generate through the renewable energy sources to the consumer. So there is a power plant at one end, it's a renewable energy power plant, which could be hydro, which could be a wind, or which could be solar. And on the other end of the power system, you would have the consumer who's using that energy. So in the middle, that stands the national power system. which has a high voltage, the medium voltage, and finally the low voltage at the consumer side. So when you talk about leveling up the renewable energy or renewable energy in feed, as we technically call it, into the Sri Lankan power system, we need to consider number one, how we can have more renewable energy power plants, and number two, how we can transport or transmit the power generated through renewable energy sources to the consumer or to the end user. I'll first take renewable energy generation and then we'll discuss the renewable energy transmission. So when it comes to generation, we have a couple of options. When you talk about hydro, in general, we know that the hydro potential in Sri Lanka is generally being exhaled. We have already used that. We do not have a potential for large hydros anymore in Sri Lanka. I might not be very correct if you ask me what happens to Moratuwa, because there is a power plant going on in Moratuwa. And there are very recent power plants like Moragahaka that being set up very recently. So have we really run out of the hydro potential? I would say no. But the potential is very limited. Yes, you can come up with power plants, but they might not be really big power plants at Victoria or Kotmale. At the same time, we know that the large hydropower plants do depend on the difference of the head. If we take the technical term, in layman terms, difference of the height or the elevation between the tank or the reservoir and the power plant. So we have a reservoir at a very higher level and a power plant at a lower level. So the difference of this level, so the difference of the elevation, is what converts hydro into energy. So Sri Lanka being a small country which has a limited hill country, hilly or say mountain area, we have already run out of the hydro potential. So that's why our discussion interestingly comes into wind and solar. So what we can do about wind and solar to level up the generation. For wind, obviously, this comes down into setting up more wind plants in the areas where we have the wind potential. If you just Google and see the wind potential map in Sri Lanka, you will see that the highest potential is in the belt, starting from Mana to Jaffna. And that's why we see a lot of wind power plants installed, around 200 megawatts, with the recent 100 megawatt named Tamba Power, I guess the recent one is being added by the Ceylon Electricity Board, as I remember. The power plants are majorly either in Mana or in the Jaffna Peninsula. That's because that is the area where Sri Lanka has the highest wind potential. So we have the option of setting up more wind power plants, and I know that there is a proposal to set up 500 megawatts. It's true that the discussion went a little politically sensitive, which because of the recent discussions of the core so on and so forth. I'm not going to discuss them in detail, but what we know is that there has been a feasibility study done to set up a 500 megawatts in Mana, Putlam and Jaffna area. So we know that will come up eventually in Sri Lanka, 500 megawatts at least as the next step. So that's about wind. So what about solar? For solar, we do have solar parks, as we call them, or I would say medium scale solar power plants being set up in the range of 1 megawatts to 10 megawatts in different areas. We know that we do see a lot of plants coming up in Hambantota area where they have a really good solar potential. At the same time, we see the rest coming up mostly in the north central area. We'd say from Kilinochchi to Anuradhapura, I would say, along the A9 and both sides of the A9, where you don't have the forest coverage, so that you don't have to cut trees to set up a plant. At the same time, you have a really good solar potential. So there are solar plants coming up. We know that Ceylon Electricity Board tendered a couple of 60 megawatts in 1 megawatt multiples which has now been installed, tested, commissioned, and now generating and feeding power into the Sri Lankan system. So that's how Sri Lanka will increase the solar power. So I'm pretty sure that there will be multiples of 1 megawatts to come in the future. And Sri Lanka has determined that there could be around 700 megawatts of solar to come in the next generation plan. So I'm pretty sure within the next decade, Sri Lanka is planning to add around at least 500 megawatts through these renewable energy sources. And the next point to level up and the most controversial discussion is through rooftop solar at the lowest level. So that's why I said having a little understanding about the power system is important, because the wind power I discussed about and the solar plants I discussed about would come at the 33 kV level and feed into grid substation. I'm pretty sure all of you have seen grid substation. Grid substations are the nodes of the power network, power system. So where you would plug a solar plant or a wind plant is to a substation. So it would take your power or absorb the power from wind plant or a solar plant, then put it into a higher voltage which will transmit the power across the country, and then whoever's using the power from different nodes of the country will use it. But when it comes to rooftop solar, the story is different, because you will plug a solar system into your own house next to your energy meter. That's how it happens. You will have rooftop solar system which is connected just next to your meter, which means the entire solar power which is being generated on your roof is going to get fed into the power system at the low voltage level. So this is again an interesting area. To be very honest with you, I'm not aware of a quantified number of rooftop solar power which would come in the near future, but I might be able to tell you that I'm pretty sure that there will be rooftop solar coming up in the near future. Because why I can't tell you a number is because that depends on number of technical limitations or say technical constraints which Sri Lanka has not addressed as of now. So I'd say we will level up in wind for at least 500 megawatts in the near future by setting up plants in Putla, Mana and Jaffna area. We will increase the solar potential, I'm pretty sure, with something around 200 to 400 megawatts by setting up small scale solar plants in the tropical areas like down south close to Hambantota and the areas in the northern and north central provinces, as well as we will have some solar energy leveled up through the rooftop solar, which I'm not in a position to quantify or predict at the moment. But I'm pretty sure something close to 800 to 1000 megawatts in renewable energy is coming up for Sri Lanka.
Yes. As of now, Sri Lanka is in a goal to achieve a 70% target of transforming to renewable energy by 2030. So my next question is, what has Sri Lanka done so far to achieve this goal? And we have 8 more years. Will Sri Lanka be able to make it renewable to 70% by 2030?
If you ask me what my opinion is, number one, I'm pretty positive about the target Sri Lanka is having. Well, just to clarify you, having 70% renewables in energy by 2030 is a policy decision. It is a policy decision taken by the government. So it now becomes the responsibility of the people and the authorities to meet that. Now that you ask me whether do you think I believe this is achievable, I would say yes. Now, if I tell you just the statistics, I had a look at the last working day just because I was about to record this today. I had a look at the uh, the statistics of 15th July in Sri Lanka. If you look at the energy generation, fossil fuel against renewable energy, we generated approximately 50%, that is 20 gigawatt hours using fossil fuel, and the balance 20 gigawatt hours using renewable energy sources, namely hydro, wind, and solar. So, which means that you can say that within that day we have been at 50% target. We have used 50% in renewable energy and 50% in fossil fuels. But this is an exception, or I would say this is a good day. But there, if you take the average of 2020, is the most recent year where I have the full statistics. In 2020, Sri Lanka generated 36% in renewable energy and 64% by the balance using thermal, that is coal or oil. So at that point in 2020, we were at around 36%. So looking at that figure, 70% seems a little far away for us. But I would say I am positive and I am expecting. And if that's the case, how can we meet that? Because just by setting up a target or a policy to meet 70% of the renewable energy by 2030 is not going to make that. So how can we really reach this 70%? I would say number one is because solar plants, we see they are progressing. So setting up a solar plant is not a tedious task, to be honest. Setting up a 1 megawatt solar plant is not that expensive. It was in 2020 around say 100 million worth of investment, which is not an impossible investment for Sri Lanka to do. At the same time, they had a recovery of about 10 to 15 years, which is a good deal if you think about financing. But I'm not talking about the situation in Sri Lanka right now, because Sri Lanka is not in a good position to do investments. But in general, if you look at the statistics of Sri Lanka in 2020 and look at the statistics of the globe as a whole, setting up solar plants is a profitable business to do. And Sri Lanka had a good model of doing that. And we do have substations around the country to which we can absorb solar. So I think if we take a rapid increase in solar energy, we will be able to reach a good number, which should be 70% by 2030. So increasing solar is a really interesting thing we should be doing, and I'm pretty sure Sri Lanka is doing that. And wind also, because I just discussed that having 500 megawatts into the system, and by doing that, we will be able to bring down, increase the renewable energy to reach 70%. So we should also keep in mind that when we say bringing up renewable energy to 70%, that also means that bringing down fossil fuel to 30%. Now, what could be the challenges, if at all? Because I said I'm very positive. So I want to increase renewable energy sources so that we can meet 70%, which Sri Lanka is doing. The other hand, we will be bringing down oil and coal plants to 30%. Now, what could be the challenges? Now, you would think, oh, what could be the challenge? We will just ramp it down, or we will just decrease. That's all you got to do.
But yes, actually that is the challenge we have to face when we are going to scale up the renewable energy use to 70%. Truly, we need to reduce the oil and coal usage in Sri Lanka. When I get ready for the podcast, I saw one YouTube video that was about Sri Lankan survey of nearly 200 families living in close proximity to Moratuwa coal power plant, found that they experience higher rate of illness, especially cancer, reduced life expectancy, as well as premature birth, miscarriages, and low birth weight. That's why today we are talking more about green technologies. So my question is, what are the benefits of renewable energy sources that we don't discuss generally?
I think you already said really good one, because when we use coal and when we use fuel oil, they are not the best for the environment. At the same time, they do have, I agree with you, I'm not aware of the survey, but I do agree with you that when you use a coal power plant, there is fly ash as a result of the combustion process, which contains sulfur. So there is a process, not that they are releasing sulfur to the environment. They don't do that, because there is something called a dust extractor, usually a static dust extractor, which works on the static what do you call it, a static extraction process, which would keep the sulfur ions within the plant without releasing them. But there is a chance that some getting escape from that, depending on the quality standards you maintain, and creating the side effects too. We cannot deny it. And that is one good reason. But I would see some other reasons as well. When you go for renewable energy, you would have less dependency on fossil fuel, which means we are a country which would import fossil fuels all the time, or completely. We import everything. We import coal, and we import crude oil, or we import diesel and heavy fuel oil, which we usually use in power plants from other countries, which means we need a lot of foreign currency to do that, which is exactly the problem we are facing these days. And there is a geopolitical dependency as well, because we need to import them anyway. If we need the neighboring countries there's a possibility of taking an upper hand in terms of economy, as well as in terms of geopolitical parameters, because we do not have any other option. We have to import them. So it depends on the fluctuations of the world market. It is really dependent on the countries who would export fuel oil to us, and it would also depend on the countries who can help us in terms of loans and foreign currencies, because we need foreign currency to import it. So that is another important fact that we usually don't see. If we go to renewable energy, initially we might have to do an investment for which we might need foreign currency, because we need to bring in a lot of machinery which we don't have in Sri Lanka. But in the long run, we will be less dependent on fuel, which means we will be more economically independent as well as politically independent. At the same time, we will be able to save foreign currency, which we would otherwise burn in these plants to do something more useful in the economy.
Yeah. Actually, when we look at our less privileged families, they also have some kind of interest in green power. Normally, they search how solar power systems work and how they can benefit from it, and so on. So, but with the initial cost, they are not in a position to implement those. Considering those facts, I would like to ask, how could we effectively and smoothly transform people to use renewable energy sources?
It's a really interesting question, Eranga, because it's true. You are very correct when you said there is a significant initial investment to be done as a capital investment. But at the same time, we should not forget that the cost has been coming down drastically. If you just look at the numbers, the global numbers, in 2010, usually it did cost 30 cents solar generation unit, whereas in 2020 it came down to 5 cents, which means it just 1/6, or it came down even less than it was a drastic reduction from like 100% to 18%. So the initial investment, even though it is huge, yes, it has been coming down. But at the same time, I do agree with you, because Sri Lanka has a spectrum of different economic levels. If you look at the families, there could be differently privileged families who cannot afford to set up a solar system. An interesting thing Sri Lanka did some time back with the help of the Asian Development Bank, that Sri Lanka introduced a loan scheme. They called it Surya Bala Sangramya. That was the commercial name, but the actual story behind that is that Asian Development Bank gave a loan to Sri Lanka through commercial banks in Sri Lanka, which the commercial banks in return gave to the general public. So the interest rate was something around 4%, which is much lower than the usual interest rate of the bank loan or a personal loan in those days. And people could take that loan, set up a plant, and then from the revenue they generate or the savings they make, because they will be generating solar energy which they don't use from the grid, through the savings or the excess money they make through this, they can repay the loan. So in general calculations we have done, a system set up in Sri Lanka usually did pay back between 5 to 7 years, whereas a solar system would stay on your roof without a problem if you use fairly good equipment. Obviously, you will sit in your rooftop for a maximum of 20 years, but generally 15 years. So if you pay your loan within 7 years, you have another 7 years free of charge for you to generate electricity, either to keep it for yourself for consumption or to sell into the grid for earning money. So for a smooth transformation, I think the more important thing to your question would be another financing scheme where the general public can go obtain a loan to pay the capital investment of the solar plant on their rooftop, so that through the revenue they gain through generation, they can repay the loan, which is a proven method. We did it in Sri Lanka. It's not happening these days because the Asian Development Bank loan, to the best of my knowledge, has expired and there is no any further grants came up. But I saw in ADB website there is another one coming up, so I'm pretty sure that will help. But I do agree with you that it will have a limit, because they will finance your plant, but that finance itself is about say Sri Lanka in 2020, a general 5 kilowatt single phase solar watt system would vary from 700,000 to 1 million, depending on what you use, depending on the equipment. But that is a fairly a huge amount to certain families. But to be frank with you, Eranga, if we want to do renewable, we have to go at that level of investments. I have not seen solar plants at a reasonable level for investments smaller than that. But the next interesting thing is, with the power cuts, Sri Lankans started setting up their own DIY type, that's how we call them, do it yourselves, that's what DIY, small solar plants which are outside the grid, using a commercially available equipment which are not, I would say, non-standard. They are not finished products. You would take a circuit of an inverter from one side, you would take a couple of batteries from an old leaf car batteries, put them together to set up a small system of 1 to 2 kilowatts, which would be able to power up your equipment for a limited time period. So I would say this is a good initiative, but it is not sustainable, because the equipment they use might not stand for a long time. A good equipment in solar stands for about 15 years, but these equipment we cannot expect to stand for that long period, particularly when batteries are involved. But that is another way. Somebody who cannot do the investment to go for a grid connected bigger solar plant of at least 3 kilowatt to 5 kilowatt can set up their own small solar power plant, which will feed a limited number of their equipment. But the challenge is, if you do that, you cannot connect it to the national grid, which means you are going to make your home isolated from the grid for some time and switch on your solar system, which you will use. Or you are going to split your house into two, whereas one part of that will be fed through the grid, whereas the rest of the house will be fed through your grid isolated solar system. But that is also an interesting thing people who cannot afford a bigger solar system can do. But that has challenges, because we do not have safety standards, particularly for batteries in Sri Lanka. We do not have proper standards for grid isolated systems. We do have them for grid connected bigger systems, but we do not have proper standards, proper test procedures, proper, I would say, quality assurance methods set in Sri Lanka for the grid isolated systems, which is a challenge at the moment. So I would say it is a way to do, but at the same time we do have its own challenges. But that is the way I see you can move into renewable energy without doing a significant investment.
Yeah, actually, it's very interesting. And also, I hope Sri Lanka is now in the situation where we need foreign investments as well as that type of loan systems to implement the small power systems. And also, another interesting thing is about that. What is that? Do it your own?
All right. DIY is a concept where it says DIY stands for do it yourself, which means you will set up things yourself. If you take in the simplest terms, you don't buy. You have the option of giving a company. Say you have a roof, you can tell a company to come and install a solar system on my roof. So they will bring equipment, they will bring labor, they will fix everything for you, and they will switch it on. So you don't have to do anything. You just have to sit back, relax, and look at.
Yeah.
But when you say do it yourself, what you will do is you will buy things yourself. You will buy the inverter yourself, you will buy the solar panels yourself, you will buy the cables yourself, and the switchgear and protection equipment and stuff yourself, as well as sometimes battery yourself. And then you will learn how to put them together. So you will learn how to fix cables, you will draw the cables yourself, you will fix the panels on the roof yourself, and you will fix the inverter and use the system yourself. So you don't have somebody who's capable or somebody who's doing it as a business to come and fix it for you. You will do it yourself. So that's what DIY means.
It's a very good opportunity to our young generation. In every country, young generation is the power of the nation. So looking at the current situation in our country, it is very easy to see that the young generation have very good sense of what should we do to overcome the existing problem in the country. So let us enlighten them about this industry. So what are the career opportunities in the industry for the newcomers, and how qualified do they need to be to grab these opportunities?
I think you are referring to the opportunities related to renewable energy, is that?
Yeah, yes.
Okay. If that's the case, I think in the next 5 to 10 years in Sri Lanka, we will have a lot of opportunities coming up in solar, because there will be rooftops coming up. I'll tell you why I say that, because there has to be a logic behind. Yes, the problem we have with rooftops in Sri Lanka as of now is not really the investment. I'm pretty sure there are people who can do the investment. But the other side of the problem is that the utility is not in a position to absorb that energy because of the limitations in the grid. If I tell you in the simplest possible terms, the transformers we have and the conductors we have at the low voltage level is not capable of absorbing the solar energy. If you really want to understand what I'm talking about in detail, just Google the over voltage problem when fixing solar at low voltage. Over voltage problem when fixing solar at low voltage. So you will see what the problem is, and the technical details are there for you to have a look at. And there is a problem like this in Sri Lanka, but I'm pretty sure there will be investments coming in the next 5 to 10 years, most probably next 5 years, to omit this problem by introducing at least some features of a smart grid into the Sri Lankan grid, which means that will enable more rooftop solar to come upon the Sri Lankan roofs. That is my first expectation. My second expectation is that in the way the prices are going, I'm expecting the initial investment of the solar in the global market to come down further, because we know that Chinese are heavily manufacturing solar equipment, and they are picking up in the standards also really well. So I have worked with a couple of Chinese models or Chinese brands also in solar equipment, and they turn out to be really good. I mean, they are at a really acceptable standard, which means the price is going to come down further in the future. So assuming that our economy is going to recover, yes, we will have more people setting up rooftop solar plants. And we see the bigger companies who are really interested in having neutral carbon footprint which means they want to generate in terms of renewable energy as much as they consume. For example, if you take an apparel industry, they want to generate energy using solar, which is equivalent to the energy they use from the grid, which means they use coal possibly or diesel to get power, but at the same time they do generate power from solar. So the net is zero, which means the carbon footprint is zero. So these are corporate requirements, and Sri Lankan companies are heavily investing in them, which means there will be corporates investing in solar. At the same time, there will be domestic investments coming up in the solar. That's going to give more jobs to solar companies, which means there will be career opportunities for the upcoming graduates in solar companies. But at the same time, I'll give you a small warning on that. Now that solar has become a really commercial magic, I would say, but there are a lot of companies who's doing solar. You might have to be a little careful, because they might not be everybody. I'm talking about this in general. Some companies might not be in a position to hire engineers, but they will definitely need supervisors, but they might not be able to hire engineers, and that is not something wrong with them, but that's how the numbers work. Because solar becomes cheaper and cheaper, solar becomes the prices go lower and lower. In certain cases, they are not in a position to employ engineers to do that, which is actually a practical problem we have. But we will have some jobs coming up in solar. So as far as you are a graduate having an electrical degree, or you are a graduate having a diploma in electrical engineering, or interestingly, if you have, I think, who is doing electrical and electronics will also have job opportunities, because we know that with some companies do repairs and stuff for solar, so there are some opportunities coming up on electronics as well. So that's one side of the story. I'm pretty sure there will be some wind plants also coming up, but they might not generate that number of big opportunities like solar would do, because it's going to be, say, 10 to 20 power plants maximum, even though you are going to like 500 megawatts, because there will be a bigger power plants, but there will be some opportunities there too. At the same time, when you have solar plants, the more you have solar plants, you will have opportunities for operations and maintenance as well. Because even though you see simply the plant will stay there, that is not the case. Plants do deplete their generation, plants do face problems. So there has to be engineers who do operations and maintenance to attend those jobs too. So if I summarize, you will have a lot of opportunities in solar, as I would say project engineers who would set up solar plants, a couple of design engineers who would design solar plants, and operations and maintenance engineers who would run solar plants. It is not as complex as running a hydro plant, and you don't have to be there all the time to do that, but you do have to monitor the performance, and because of which there will be some opportunities coming up in solar too. Wind will also have opportunities, and some mini hydros too, but that is not going to be as much as solar would do. In terms of qualifications, I would say you might have to be ideally an engineering graduate to do that, or a different level you'll be able to participate if you have a diploma in electrical engineering, or on the other side you might be able to qualify through doing courses like City and Guilds, where you will get to know electrical engineering and things like diplomas like in DT and TTI and stuff like that. You will be able to push in yourself into different positions of the system. I'm very sure you will have a lot of career opportunities coming up in solar and some in wind and mini hydro. Yeah.
Yes, that will be a good news as well as some advice to the youth. We talked about Sri Lanka, but the whole world is in energy crisis. When we think globally, as undergraduates, industry professionals, or electrical engineers, how can we contribute to mitigating those problems?
That's an interesting question, as well as a really wide question. So I'll try to answer that as fast as possible. You said global. Yes, that's true. But I would say if you do it in Sri Lanka, you would be doing a part of the globe too. Because when you say global, Sri Lanka is a part of the globe. And when you take energy towards the renewables, which means you will be bringing down the carbon emission in Sri Lanka, which means you are doing something very good to the ozone layer, as well as you are doing something good to the entire globe. But coming to your question is, I would say the professionals do have responsibility to do a couple of things. Number one, I would say to promote renewables, because they have the technical understanding, they know the technical limitations, but at the same time they know the truth behind this technology. So one thing they can definitely do is promoting renewables. And by saying promoting, I'm not just saying that going on social media and posting something saying that let's go green. That's not what what I would say as promoting. What I say promoting is that do things and innovate things which can increase the contribution of a renewable energy. Say, for example, if you do some research, if you do some technical work on how you can extract or how you can absorb more renewable energy into the grid, that's how you promote renewable energy. So the students can do that in their final year or in their research work, where how you can have more renewable energy or how we can absorb more renewable energy into the grid. Why I didn't say global Eranga is these questions are actually local. So if I talk about the global level, there are a lot of global movements going on. But if I really want to give a workable solution to somebody who's listening to this, I would say the challenges we have in Sri Lanka in terms of renewable energy, if you want to solve, one thing is that our grid is not capable of absorbing energy as much as we want it to, because of the limitations we have in the grid, which are the limitations we have in the passive network in the low voltage end of the grid. So you can definitely do research, you can definitely do studies, you can definitely do some research work on these and find solutions for this. I'm pretty sure, I know Pethiyagode did some really good stuff on this. So this is something you can do. And Moratuwa did the microgrid, which is a different end of the same solution. So this is something interesting which you can contribute in terms of promoting renewables, the technical one. The second part is actually the policy part, because we know that even though you want to have renewable energy, there are some legal boundaries and there are policy boundaries. For example, there was a proposal to rent your roof for somebody else, because we know that Colombo has a lot of solar, but let's say Moratuwa or Anuradhapura or Kilinochchi or Gol, Mathara, and let's say Pasikuda or Batiklo does not have that much of solar. But the actual problem is that people there do not have the capability to do the investment. So what if people there do rent their roof for someone who can do the investment to set up a solar plant on that roof? So this is a suggestion to solve the problem, but there are policy limitations, there are legal limitations. How can you do that? How can you rent the roof? People have done that in Sri Lanka, and there are a couple of court cases also going on. So there need to be a framework to come up to a way where I can rent my roof for somebody who can do the investment to set up a solar plant and generate energy, which can then go into the national grid. And the other side, when you talk about microgrids, Sri Lankans cannot get together and set up a small microgrid of their own using a couple of houses, because in the legal perspective, you are a customer and your house is a premises. You are given a meter. You are not allowed to connect with your neighbor. That is illegal. So even though how much you like to, you cannot grow a wire from your house to the house next to yours and give power to them, because that's illegal. You can't do that. But if we change these legal boundaries and if we change these policy limitations, we might be able to set up small microgrids in different areas where people can do the investment. They'll set up a small microgrid where they will have solar as well as their own small generator, so that they will run their own grid for say 10 houses, and they will divide the investment between themselves so that the capital investment a person has to do is affordable. So this is not legal in Sri Lanka. If you really want to do, you have to change the policies. You have to change the legal framework. So that's the second thing. You can promote renewable energy by bringing in suggestions and putting pressure to change the policy limitations or the legal limitations we have, so that we can have more renewable energy generation into the national grid. So I would say, if you want to really promote and if you want to contribute as a professional or a student, you can do some technical studies where you can have more renewable energy. And this is not the time to go into details, but I'm pretty sure if you just Google it, you should be able to find more than enough problems. And in the academia, there are a lot of discussions going on. Just to name a few, there is the voltage increase problem on the far end of the grid. There are static power compensators coming up. There are battery solutions coming up, and there are on-grid and off-grid solutions coming up. So there is a lot of research you can do. At the same time, you can promote the policy changes so that we can have more renewable energy.
It's very informative. Mr. Pasan, you also a chartered electrical engineer who is actively involved in the research as well as in the industry. Can you tell us your field and research experiences related to the renewable energy?
Well, to be frank with you, Eranga, I'm not in the area of research. I would say I'm in the field of designing stuff. So my expertise do lie in designing solar plants and constructing plants and control systems. So I would say I have done a fair number of solar plants in terms of designing as well as construction. So what I learned from that is that the potential Sri Lanka has, as well as how good the technology is, so that in my experience of solar, I would say it's an interesting area to study and work in. I worked as a design engineer, as well as I have worked as a project manager in a couple of projects. And I have also done some consultancy work for the plants which are not doing proper generation. So in my scope, designing comes first. If you want to put up a solar power plant, you have to design it, so that you need to know about the equipment, their technical specification, and how would you put things together, how would you put solar panels, the inverters, the batteries and stuff together to design a plant. So that's one end of my scope. The other end of my scope is actually troubleshooting the plant which does not generate the expected outcome. Because when you put up a solar plant, you expect this much of energy. We usually expect, in flat terms, a solar plant would run in its rated capacity for 4 hours within the day. That's how we usually take the rule of thumb figures. So if the plant is not doing that across an year, which means your plant is not giving the expected outcome. So there comes the requirement for somebody to go there, have a look at the plant to see what has actually gone wrong. So that's another part of my experience, where I did a couple of consultancy where I had to troubleshoot the plant to see what has gone wrong. At the same time, there's something I'm involved in these days, that is in UK, because I'm based in UK in these days, and there are crushing plants or aggregate plants which are really remote, which means they are away from the national grid, and they will use mostly diesel generators or power fed through a nearby power plant, which is not very big, to run their crushing plant. And interestingly, these plants are really big. So they have small generators placed in different places of this big quarry or the big process plant to run. And some generators do not have to run all the time. Meaning, say for example, you just have to run that generator to take the water out from the pit where you are supposed to dig in. So that generator don't have to run all the time. But the question is, there is a control system which has to run, because the control system has to be live to watch whether the water levels are coming up, and if the water level is coming up, the generator has to switch on, and then there has to be a couple of pumps in a cascade system to draw the water out. But the interesting point is that if you can power up the control system using solar and batteries, which means you don't have to run the generator for the control system. So your control system will run on solar power and batteries, so that you will run the generator only when you need to run the pumps. So your control system is always alive, but it does not need the generator. So there is, we did try this in one plant, which is actually, we completed the design, and then now it is in the construction stage. So I'm not in a position to give you the numbers about outcomes, but if that is successful, we will promote it in the UK market in the plants which are remotely located and which are really big and which have intermittent loads, so you don't have to run all the time, but the control system has to run. You can use solar. So that's an interesting thing I'm involved in these days.
Yeah. So with that question, we are coming to the end of the podcast. So we had a great discussion with you, Mr. Pasan. So we would love to know your perspective on IEEE Techverse Sri Lanka.
I see really an impressive movement you guys are taking, because I listened to a couple of podcasts, and I had to look at your program because I'm an invitee today, so that I need to know what you guys are doing. So I saw you are covering some really current technical topics, which is really interesting, because as you said, that the Sri Lankan youth we see is now taking leaps in their lives. We see that let's not go into discussions of the economics and politics, but we see that they have started to take an active role in their we would say in their responsibility or in their part to be done for the country. And at the same time, we see a lot of innovations coming up. We saw supercars, we saw battery-powered three-wheelers. At the same time, we saw some stethoscopes and medical equipment done by the Sri Lankans. And we also saw things like innovative products being securing seed funds in foreign markets. I saw a couple of seed funding coming from Australian markets, and there are a couple of products being sold and in Germany, and we see our software industry being expanded into different parts of the world, which means the Sri Lankan youth is actually converging themselves from the traditional jobs or the traditional service jobs or the traditional government jobs into innovations and into science and technology, which is a really good movement. So I see this particular product, the Tech Innovator, as a that you guys have captured the sense of the movement the youth is taking these days, because I saw you guys discussing robotics some time back, which is really impressive. It is really impressive to me that you are talking about future trends or the future technologies which Sri Lankans can do take part in this digital age. So I'm really impressive. I'm really thankful to you guys for doing something like this, and I would say this is a really useful and need of the hour.
Thank you very much, Mr. Pasan. We are really grateful to you who joined us today to have a nice and valuable discussion for our audience to make them aware of latest technology updates on renewable energy. So listeners, hope you all enjoyed it, and if you are interested in learning more about latest cutting edge technologies, stay tuned with us through our podcast platforms: Spotify, Apple Podcast, Google Podcast, SoundCloud, Radio Public, and also YouTube. We have many more sessions lined up for you. Thank you very much for listening. We'll meet you with another episode. I'm Eranga Kodithuwakku from IEEE Techverse Sri Lanka. Goodbye.